Alright, let's look at the normal distribution. Alright, so usually this is called maybe you might know this as a bell curve. Alright, it's a distribution of probability that is nice and symmetric, and it's got the nice function. So we're gonna talk about that. So you have this nice bell curve, and the average value, which is the value right in the middle, is called the mean. Alright, so this guy is called the mean. And there's something called the standard deviation, which measures how wide spread the data is. So the higher the standard deviation is, kind of the flatter the curve is. So in normal distribution, you've probably seen this in high school. If you go away from this, say a higher standard deviation, one standard deviation higher than on the mean. So I'm going to say mu plus one standard deviation is sigma. All right, and then we know that approximately there is a 34% is going to be distributed here. So between the mean and up to the one standard deviation away. And if you go 2 standard deviation away, so between 1 standard deviation and the 2 standard deviation, roughly you're going to have 14%. Right? And beyond 2 standard deviation, there are only 2% left, about. Right? And since it's symmetric, the same thing happens on this side. So this is mu minus sigma. Oh, I forgot to put the 2 there. So this is a mu plus 2 sigma. Right? So this is going to be mu minus 2 sigma. And again, so about 34% sits here, and 14% sits there, and 2% sits there. Alright, so this normal distribution density function has a formula, right, based on mu value and the standard deviation sigma value. And I didn't write that, so here mu is called, the sigma is called the standard deviation. Alright, and a formula goes like this. So this curve has this formula, 1 over square root of 2 pi sigma e to the negative quantity x minus mu squared over 2 sigma squared. Alright, so once you have this probability density function, we can find the probability. Alright, so probability of, say, the value is going to be between a and b can be expressed as an integral. So you can just integrate this density function, normal density function, f of x. Then you just evaluate it from a to b. Right? And the reason why this is introduced in this improper integral section is that when you look for probability that x is at least a, then you have an integral, so lower limit is going to be a, but x just keeps on going, so you're going to have infinity here. Now you can see that we can use an improper integral to find the probability of x being at least a. Alright, so let's look at the simple example, like test scores, right? So if you have a test scores, midterm or whatever, and let's say the average came out to be 70. So 70 was average, so it was a tough exam. And the standard deviation came out to be 12, right? Then if you're interested in finding the probability of scoring at least 85, or you randomly pick a student out of the class, and what's the probability of this person scoring at least 85. All right, so let's find the probability. So the notation would be probability. All right, so I'm going to use a capital X for the test score. All right, and it is at least 85. All right, we know that this is just going to be an integral from 85 to infinity. All right, and then f of x dx. All right, f being this guy, so maybe I should be a little bit more specific. So we have f of x is going to be, all right, so you have a 1 over square root of 2 pi. All right, then sigma is 12, so you type in 12 here. Then you have a e to the negative quantity x minus mu, mu is 70, squared over 2 times sigma is 12 squared. All right, so we have that. Then we evaluate this integral. We should be able to find the probability. All right, so in order to do that, I'm going to use Geogebra to compute it. So let's open it up. All right, so we open up the Geogebra. So I'm going to type in mu. So if you click on this alpha, we have all kinds of Greek letters. So mu is 70. So set that to 70. So we got that. And also sigma, which is a standard deviation, is 12. So put it in. All right, then we can just type in, so we can define the probability density function f of x is equal to, all right, so you're going to have 1 over, all right, and then you're going to have a square root, so sqrt, square root of 2 pi. So you can just say, type in pi. So 2 pi. And actually, I have to make sure that I have to put the, then I'm going to put multiply by sigma. All right, so put sigma in there. All right, so you have a 1 over square root of 2 pi times sigma. All right, so we have that. Then we have a e to the, we can do exp. All right, so here you have exp, then e to the, it's going to be negative quantity x minus mu. So we have to put mu there, mu, and you have to square that and divide it by, and the 2 sigma square. So we put the sigma here, squared. All right, so all I did was typed in this normal density function here, all right, into Geogebra, and then it came out to be that. All right, so Geogebra automatically puts 70 for mu and 12 for sigma. So we have that. All right, let's see if what this guy looks like in the picture here. So this guy, Geogebra, draws the picture for us. So mean is 70, so we should probably pull that over. So mean is around here. All right, then I'm going to stretch it out so that you can see the curve a little bit better. So this is the bell curve that we're looking at. Right, so this is the bell curve. So you can see that the mean is 70 and standard deviation is 12. We can stretch it out if you want to see it like that. All right, so then what we want to do is we want to know the probability of at least getting 85. So 85 is probably around here. So we are looking at the area, and so the area of this small region here. So we want to find that. All right, so let's find that. So we want to find the integral. So what we want to do is we can just say integral. All right, So it gives you a bunch of solutions. We want the starting and ending one, so we choose the third kind. Right? Integral of this function is we already defined, so we can just say f, right? And a right arrow to go to the next one. Starting value is, remember, at least 85, so we're going to put 85 there. Right? End value, we're going to go all the way to infinity, and hopefully there's an infinity symbol somewhere hidden. Yep, there's an infinity there. Right? So this is basically an integral of integral from 85 to infinity, so improper integral of f of x dx. Right? So let's find the value here. Right? So hit enter, and here. Alright, you can see that that value came out to be 0.11, which means that approximately 11% is the probability. Let's see, if you want to see a little bit more, you can change the, if you want to see 3 decimal places, you can change that. So you can see that it's actually 10.6% of the probability to get at least the 85 on that test, which is fairly rare. So it's it's about 11%. All right. So that's how you use normal distribution given information and try to determine the probability of scoring at least certain points. All right. That's it. I hope that this was clear.